Welcome again to this webinar session on Big Data and Hadoop. Right. So for today's session, we would be covering the basics of Big Data. So this is the agenda that we are targeting for today's session. Right. Before I start, let me just introduce myself. My name is Jaimin Patel. I have over 10 years of software industry experience, and I have worked with a couple of product companies developing softwares. Have been working in various technologies, Java, J2E, and over last 3 years I got an opportunity to get my hands dirty on big data technologies, and that's where I get a chance to work on Hadoop. And since last 3 years, I have been working every day using Hadoop technologies, and we solve a lot of business problems using big data platforms. We have in fact built one analytics platform where we do a lot of analytics, and we run a lot of analytics jobs, which provides analytical services to the customers. Apart from that, I also like to have a conferences, open conferences with people who are like-minded and who want to share and do something innovative in the big data space. So we conduct a lot of conferences and open house sessions in the similar area. And I also possess tremendous interest in sharing the knowledge that I have gained over years for big data technologies with the people who are interested to learn about that, and that is the reason we are meeting here. Starting with understanding big data, where if you think for a minute, any new technology or any new thing that we want to learn, we need to first understand, or we need to first make sure that we get two questions answered clearly, which is what is that thing that we need to learn and why we need to learn that, or why we should learn that, right? So that is what I'm going to focus on today by covering understanding big data. Now once we cover that, we will understand, all right, big data is definitely an important area where a lot of companies are investing a huge amount of money. So what are the technologies and tools available to work with big data which can help us solve some of the business use cases with big data? And that is where we will introduce Hadoop in this group, right? And we understand the high-level definition of what is Hadoop and why it is used, right? And the last part of the session will be covering Hadoop ecosystem. I'll be just touching upon some of the keywords that I'm sure you would have already heard about, which creates Hadoop ecosystem. Okay. Now, before I start taking the each topic and explaining that, let me know if anyone has any questions. You can always post your questions, and as we just discussed, the Simplilearn team would definitely get back to me. They will tell me the questions, and we will respond. We will address those questions as and when it is asked, right? So we will also give you last 5 minutes of this session where there will be question answers, and if people want to ask specific questions or they have any specific doubts, they can always get it clarified. So all right, let's talk about big data and let's understand what is big data. So as the name suggests, right, if we really want to understand what is big data, the first thing which comes to our mind, right, by reading the word itself is lots and lots of data. It's about volume that comes to our mind, right? Massive amount of data, about terabytes and petabytes of data. But can I say if I have huge volume of data, I have big data? Now that's where we really need to pause for a while, and let me introduce some of the real world scenarios to you, and before we formally define what is big data. Okay, so I have captured some of the slides here, some of the images from different industry sectors. First image is an aeroplane, right? So basically an airline industries, they are how they are using big data and what are they trying to do with that. So the stat says that an airline jet collects about 10 terabytes of sensor data for every 30 minutes of flying time, right? So which is a massive volume. So if you can see about 30 minutes of flying time, an airline can collect so much data because they have something called a black box system in the plane, which records, they have a lot of sensors attached to it, and those sensors records each and every event that happens during the flying time, right? So now what they do is, by collecting so much information, this information is a very valuable information, and what they do is they actually they analyze this information, they process this data to solve some of the business use case. I'm sure there will be a lot of business use cases, but we will not go in each and every use case that airline industry solve, right? So what we do is, I'll just take one use case, which could be, to improve the quality or performance of a flight, right? How do we make sure that the flight time and the performance is cost effective? So that is a major problem. That is, I would say, a major business use case for any airline industry. And if they want to, if they solve that, definitely they'll get a lot of profit. So these informations will help them solving that business use case, right? How they are solving it, we would not cover in today's session. We would definitely talk about how part of it when we get into the actual trainings, right? Let me also talk about another use case, which is about stock exchange, right? So I have just put a image of New York Stock Exchange, and that image is, as everyone, I'm sure everyone is aware of, stock exchange. People trade stocks. They just trade day in, day out. They sell and buy stocks of different companies, right? So even the stock exchanges with such heavy transactions, they generate terabytes of data per day, right? Now, if you can see, there is a lots and lots of valuable information in terms of this transaction which is being generated every day. Now, there are specific analytics company available who are actually interested in predicting the market trends or predicting the value of a stock of any particular company. So what they do is they actually write high frequency trading algorithms, and these algorithms are fed with lots of data which the stock exchanges generated over a period of time. And based on that, this algorithm predicts how this stock is going to perform over next couple of days or next couple of months based on the previous past historical record that it has with the stock exchange, right? So these companies will actually try to perform stock trading analytics to determine optimal trends, right, for any particular stock. And they do this using definitely Hadoop as one of the technologies with which they try to solve such business problems, right? Let us go to another example, right? Facebook. I'm sure everybody uses Facebook every day, right? It has become part of our life. People do a lot of social networking, these days, and they get connected to various friends, families, relatives. Now I'm not going to explain what we can do with Facebook, but the important fact that I have gathered here, which says Facebook has about billion users across the globe, and about 250, 300 plus million users in the US itself, United States of America. So what I'm trying to highlight here is Facebook has huge amount of users, right? Now Facebook has published a state which says that every 20 minutes on Facebook, lot of activities happens. And I'm just going to draw some of the important part here, which is like, you do link shared, event divides, friend request accepted, photos uploaded, messages sent. So all these activities that you are doing, right, and when all the users across the globe are doing these activities in every 20 minutes on Facebook. So you can say that so much data is getting generated every 20 minutes, right? So that's a massive amount of data that we are talking about. Now what Facebook does with this data? So Facebook actually, by the way, Facebook has a lot of revenue streams, but one of the revenue model that Facebook has is through advertisements, right? So what they do is they analyze the data that they have of a particular user. So every user has a Facebook profile, right? And every user does a lot of things on Facebook, and that defines the behavior, the character, and the nature of that user. I mean, what that user likes, what that user does not like. Cover here is an advertisement as a use case. So before I get into how Facebook does the advertisement, I also want to tell you one thing, which is, if you can see, about 10 years or 15 years back, there was an era of advertisement where people used to show advertisements for any particular product or a brand uh, to generic set of users. They don't really care whether a particular user was interested to see that advertisement or not, right? And that type of advertisement is called mass advertisement. So earlier days, the mass advertisement was very prevalent in the market. Even these days, if you see on televisions, everybody has televisions in their home, and if you see two people sitting in different geographical location watching the same channel, same program on the TV, may see the similar ads, same ads on the same time, right? It may so happen that one of the user would not be interested in seeing particular ad, but the other user might be interested. But irrespective of whether a user is interested or not, still he has to see the ad, right? So that is called mass advertisement. Now what Facebook did, Facebook, with the invention of this analytics with the help of these technologies related to big data, what they did is they analyzed this data and they came up with a beautiful concept called targeted advertisement, which means rather than showing an advertisement to a mass set of user, now they are showing an advertisement to a particular user, right? So what they do is they analyze the data of a user, they understand the interest, likes and dislike of that particular user. So now they know exactly what advertisement I should show to this user so that he or she may be interested to do some transaction with that product or that company. So for example, if a user who's doing a lot of activities on sport, who has uploaded a lot of videos and photos related to sports events, or who's actually doing who's joining a lot of sports groups, attending a lot of sports events. All these informations are there on the Facebook page. So Facebook has analyzed this data and found out that okay, this user is pretty interested in sports activity, so let us show him an advertisement related to sports brands, or if any sport event is happening, let us show him the advertisement for that event. And chances of that user going to that particular page, visits and doing some transaction would be very high. And that is how Facebook increases the chances of generating revenue, because once a user clicks onto this advertisement, on every click Facebook gets some share of revenue from this advertisement companies. Apart from that, if a user goes and visits those pages and does some transaction, Facebook gets a revenue. So if you can now relate, I'm sure you will appreciate this, that it is very important for Facebook to do this analysis very accurately, right? So that they can increase the revenue, increase the chances of their revenue by making more accurate analysis. And that is why they have to do this accurate analysis using the technologies related to big data. And Facebook also, by the way, is using massive clusters which are running on Hadoop. Okay, so during our actual training sessions, I would be covering some of the use cases of Facebook, and we'll understand how they use that. So that's one part of Facebook. And since we are talking about Facebook, I also want to highlight one very important deal which has happened a couple of months back, that Facebook has taken over WhatsApp, right? I'm sure everyone knows that. So I'm sure everyone knows why they have taken over, but I just want to highlight that point. If someone has taken over WhatsApp, we really need to understand why such a massive deal happened, about $19 million. Because Facebook, it's not that because of the software they paid that price. Facebook could have developed WhatsApp like Messenger very fast and probably better quality. But they paid the price not for the software, they paid the price for the amount of data that WhatsApp already had, because they have lot of wealthy information from different users, their contact details, and lots of information of these billions of users, registered users. And that is the asset that Facebook wanted, and that is where they paid a hefty price for that. So that is just a use case that I just wanted to highlight. So basically, again, Facebook paid a huge price for data, basically acquiring a data. Okay, so that's another use case. Similar use case is Twitter, where again Twitter also does the a similar thing, where any company who want to market their product can go on to Twitter and basically market their product. Twitter can fetch them the right set of users who are interested to buy their product, because they also do a lot of analysis over the data that they have for a particular user. So Twitter also follows the similar model, and they are also using a lot of analytics using big data. Okay, so these are some of the use cases that these companies solve using big data technologies. Now let us define big data. Let us formally define what is big data. So IBMs are the ones who came up with the big data definition, who has formally defined what is big data. So by the way, you can characterize the big data into 3 different buckets: the volume, the velocity, and variety, right? So if you really want to, so let us understand each bucket. So volume means, as the name suggests, it's actually huge amount of data. It's about terabytes and petabytes of data. So once you have huge amount of data, remember we talked about, can we say we have a big data? But the answer is no. We really need to also look into other parameters. Another parameter is velocity, which means if you have a huge volume of data, at what speed that data gets generated into your system, or that data comes to your system, right? So let me give you an example. Let's say you have about terabyte of data which gets generated in your system after every, let's say, 1 year, right? That is one use case, one scenario. And now the another scenario is, let's say you have 1 terabyte of data which gets generated into your system after every 1 day. Okay, now you can see the difference in terms of the frequency, right? One use case, we have 1 terabyte of data gets accumulated into our system after every 1 year, and another use case, every day such huge amount of data keeps coming to my system, right? So definitely velocity plays a major role, right? So first case would definitely not fit into big data because we are really talking about higher velocity. The third bucket of big data is called variety, which means what type of data we are handling or we are talking about, right? So by the way, at a high level, you can categorize the big data into 3 different buckets. Any type of data into 3 different buckets, which is structured data, unstructured data, and semi-structured data. So let me just spend 1 minute to define what are these. Structured data means any data that you can store on a relational database systems like your normal OLTPs like Oracle, MySQL Server, SQL Server, MySQL, and all that. So these are the data which gets stored in the table, rows, and column format are called structured data. Then what is unstructured data? Unstructured data means any, let's say, images, photos, videos, audio songs, audio files, video files, all these type of data are called unstructured data. Even the log files that get generated by application servers, these are also unstructured data. Why? Because specifically unstructured data is very sensitive and so by the way, XML files, or I would say JSON files, are the very good example for semi-structured data because they represent the information in the form of XML files represent tags where you can define tags in a hierarchical order, means there is some relationship between them, but the value that you put inside each tag can be anything. So that is unstructured part of it. So that's why you have some structured and some unstructured part, and that is why XML is an example of semi-structured data. So if I want to summarize what is big data, you can just say that if you have huge volume of data, about terabytes or petabytes of data, which gets generated into your system very rapidly, and it can contain any type of data, then you can say you have a big data. That is the formal definition of big data. Okay. So I just want to put a pause here and really wait for a couple of seconds to just check if someone has any questions for me. Simplilearn team, can you please confirm if someone asks any questions? All right, looks like we don't have. If we have, we will definitely get back to you. So let me continue forward. All right, so this slide talks about unstructured data explosion, which means if you can see this slide, you will realize that early 2000 or late 1990s, till that point of time, actually the data volume was very less. Only the transaction data was there over across the globe. But if you can see from early 2000 onwards, the data curve is actually exploding like this, which is basically a hockey stick growth. Okay, and that is the massive that actually leads to the massive opportunities related to big data. A lot of companies have shown a lot of opportunities in this space that they can do to remain competent in the market or gain the competitive advantage over their competitors. Right? There are some stats that I have just captured here, which says that digital universe grew about 62% last year, and it will grow to about 1.2 zettabyte this year, which means every year the massive volume of data is getting accumulated, and which leads to lots and lots more possibilities related to big data. Right? One of the primary driver for this growth is internet. Right? Nowadays everybody has a lot of widgets and gadgets through which they can connect to the internet, and they actually do lots and lots of information. They share, they upload photos, videos, they do a lot of activities on internet, and they basically increase the volume which is specified here, right, with that kind of activities. So this is basically an informative slide which talks about the growth of the data every year. Okay, so now let us try and understand. Okay, I just got a comment from Simplilearn team that some of the participants cannot hear me. Can you please confirm from other participants who can hear me well? Can you hear me well, by the way? How about now? Is it better? Okay. Can you just check with all the participants if they can hear me? All right. Okay. All right, everyone. So what we understood as of now is what is big data. So can you please check with the team if anyone has any questions as of now, or everybody understood whatever we have covered so far? Can you just quickly confirm me that? Okay, all right. So let me continue forward. So basically now we have understood what is big data. Now we will be understanding why big data is so much important, right? So I'll just take, I have gathered a couple of use cases from different industry sectors. Now what I'll be doing is I'll be actually covering only some of the important use cases for today's session, and when we get into the actual training we will get into the details of each and every use cases, right? So if you can see, there are different industry sectors like web and retailing, telecom, finance. So let us talk about the use case from these industry sectors and understand how they are using big data technologies to solve such use cases, solve such problems. One of the use cases called generative AI. These companies, when you do online shopping, right, the next time when you do any shopping with this company, when you log into that website page, they will already have the transaction history that you have done with them earlier, and based on that they analyze the data and they recommend you set of products, right? So if you can see, they will show you which products are important and which products are basically you would be interested in buying. So you will, most of the time you will, you know, come to know, or you will realize that the transaction that you have done already with these companies, the kind of product that you have already bought with these companies, they will be recommending you the similar products from the similar category and also the similar price range, right? And that is where this recommendation engine use case comes into picture. So what this company does is they run a lot of machine learning algorithms on top of this data, and they try to build this intelligence over the data and find out whether user is particularly interested in which all product categories and what price range he is looking to buy the product for, right? uh, by the way, recommendations is one of the area of machine learning, and a lot of algorithms are there to solve different problems in that area. So these e-commerce companies uses these algorithms to solve such use cases. Now what the stat says that these kind of recommendation use case that they are actually showing to the customers, it will give them about 60 to 70% hit ratio, which means, let's say a person who's logging into this websites and who tries to, let's say if a user who logs into a Amazon website and he will be recommending some products by the websites, even if the user who's not interested to, or who has not made up his mind to buy any product, by looking at this recommended products, the chances of him end up doing any transaction would be about 60 to 70 percentage, right? And that is actually a massive passive marketing, I would say, which they are doing, and that is very important thing for the business. So that is one such use cases that they are solving. Let me take one more use cases from another industry sector, which is telecommunication, which is called customer churn prevention. If you can see here, this is the use case I am talking about, customer churn prevention. So these telecommunications industries, what they do is they basically have they are the telecom service providers to different users. Now let me just take some examples. Let's say there are two companies, company A and company B. These are the two telecom service provider companies in United States of America. Now these companies, what they do is, let's say there are users who are using services from company A, and there are some users who are using services from company B. Now it may happen that some of the users who are using services from company A may leave them and join company B, or start using services from company B because they were not satisfied with the services that is provided by company A, or they may not get the correct network coverage, or they may be the price range would be very higher, or they may got competitive prices from their competitors. There could be various reasons why they are leaving them. So what this company does is the company A would actually have all the details about why their customers have left them, and they analyze these reasons by again using these technologies to find out what are the top 10 reasons why majority of my customers are leaving us, right? And they try to come up with a better competitive offers or better solutions to those reasons, those problems, to make sure that we can avoid such customer churns in future, right, by solving those problems. And that is one very good way of retaining your customers, right? It is very important for any business to retain their customers, and that is how they do it using this technology. So that is one such use cases that I wanted to talk about. Okay. Now similarly, you have a lot of such use cases. Let me tell you about one of the use cases that that is being handled in the government by government of India. Uh, uh, it is called Aadhaar card. So people who don't know what is Aadhaar card, it is very similar to a social security number that you have in United States of America, which is like a unique ID for every citizen in that country, right? So this massive project got implemented about few years back, and now all the people are having this unique ID with them. So the implementation of this entire project is being done using Hadoop and HBase as the underlying technologies, right? And by the way, Aadhaar card is called the world's biggest biometric database just because of the sheer volume of the data that it has, or it has to process from this country, right? So that is also one such use case where these technologies are heavily used. Another industry sector is healthcare and life sciences, where you have a lot of use cases that can be solved. I'll just talk about one of the use cases called drug safety. So any pharmaceutical company, when they release a drug, right, what they do is they actually tie up with big hospitals and they release that product to them. Now these hospitals, doctors in that hospital will prescribe these drugs to
The broadcast is now starting. All attendees are in listen-only mode.
Okay, so what happens is basically they are actually marketing these drugs, and after this drug is being applied to different patients over about 6 months or 1 year, these companies collect this data from different hospitals and they analyze this data to find out how this drug has performed over a number of period, right? And based on that, they take a decision whether to improve the drug or whether to add more ingredients, or whether to completely remove this drug and come up with a better version. So such questions they try to answer by analyzing this data. So that is one such use case where healthcare and pharmaceutical companies are also using big data heavily, right? Another use case that I would take up from bank and financial services, which is called credit scoring and analysis. I'm sure many people know about credit scoring, so I'll not talk about how credit scoring is derived. But credit scoring and analysis is actually one such use case where banks rely it on heavily before they give loans to any customers, right? So I'm sure everyone knows about credit score. So every individual will have their credit score based on the financial wealth and financial history that they have with the different banks. Now once they have this credit score, when a user goes for a loan to any particular bank, what this bank does is they actually check all this historical data of this user, and they can easily get this data from all the banks where this user is holding an account, because these days all the banks are centralized, so they can easily get this data and they can analyze this data to find out what is his income pattern and what is his spending pattern, and based on that they come up with a analysis saying that whether this particular person he will be able to repay the EMI in a given period of time, right? So even the user may not know how much money he would have or she would have after some months of time or 1 year of time, but with this analysis banks can give you that answer, right? So that is where banks are also, just to get this analysis done correctly, they are using these technologies, big data technologies heavily. Okay, so these are some of the use cases that I wanted to talk about. In the interest of time, I would probably not go in detail about that, but definitely during our training we will various real-world use cases across different industry sectors, right? So I hope everyone is fine as of now, and then I'll just spend a couple of more minutes in covering the remaining topics. So before I move further, is anyone has any question? Okay, okay, looks like we don't have, so good, so let's move forward. These are some of the Hadoop users that you may have heard about. These are some of the big names in the industry, but there are lots and lots of companies who are using Hadoop. The list is very huge. Okay, so now we have understood what is big data and why big data is so much important. Now let us understand what are the technologies that can help us work with big data and how Hadoop has become the most effective technology to work with big data. In the interest of time, I would not cover in detail of that, but what I will cover is what is Hadoop and how it works with big data, right? So before I go into Hadoop, I'll just spend few minutes in explaining what is distributed file system, because when you talk about Hadoop, Hadoop is a framework which gives you two important features. One is to store data in a distributed manner, and another one is to process the data in a distributed manner, right? So when I say distributed manner, it is nothing but underlying system that Hadoop uses to store the data is nothing but distributed file system. So let us understand why it uses distributed file system, right? So I have just given two different use cases. If you can see here, you have one use case where you have one machine. Each machine has 4 I/O channels and 100 Mbps speed. Now if I want to read 1 terabyte of data which is stored on a single machine, how much time does it take? So let us say it takes about 45 minutes, right? Let us not go into the calculation of how it has taken that, but let us assume that okay, it has taken 45 minutes. Now there is another use case where it has already spoken, where let's say instead of taking one machine, what if I store this data into 10 different machines? Okay, so each machine, by the way, the configuration remains the same. They will have 4 I/O channels and each channel will have 100 Mbps speed. Okay, so let's say if you divide your data or distribute your data into 10 different machines, and then now if you want to read 1 terabyte of data, we can definitely read it using parallelization. So how much time it will take? It takes about 4.5 minutes. Okay, so which is much faster. So that is one of the fundamental reason why distributed file system exists, why it is needed. Okay, now what is distributed file system? So the distributed file system is nothing but it's a virtual layer, or it's a piece of software or set of programs running on top of your machines, which takes care of storing and retrieving of the data from different machines which are connected over network. Okay, so let me just give you one example of that. Let's say you have about 1 terabyte of file. This is 1 terabyte of file which you want to store. Let's say there are 4 different machines, physical machines in this diagram as it is being shown. They are, let's say, geographically located differently. One is in Chicago, one is in Houston, one is in Denver, right? And these machines are, let's say, connected over a network. So they form one, they form one cluster. Okay, let us not worry about what is cluster. We will understand that in the actual training sessions. So let's say you have 4 physical machines. You want to basically store the data. So this 1 terabyte of file will be divided into 4 different parts: part A, part B, part C, part D, and each part of the file will be stored in different machines which are located geographically in a different places, right? So this is a physical storage, but how does it store? So user will not know that it has to divide this file and then store the data into different machines. It is all abstracted out from users. So what user does is, let's say this is the file and the file name is, let's say, F1. I'll just give some name, F1. So if, let's say, user stores the data under some path, let's say user data /F1, that means this is called SDFS path. Okay, so basically there is one abstraction or virtual layer which is running on top of all these machines, okay, which basically is nothing but it's not a physical file system, it's a set of programs which are running, which will take care of dividing the data into different machines. So when you store the data into this particular location, this location is an SDFS path. So user will not know whether he will just think that, okay, I am storing this data in a particular location in a single machine. Okay, but internally, because it's stored in an SDFS or basically a distributed file system, these programs will intelligently divide this file into different parts like this and store them into different machines. So these programs will remember which part of the file is stored in which machine, right? So let's say next day when the user comes and he wants to retrieve this data or read the data, he will just say cat and this path, okay, this entire path that I have written above, okay, the same path. So when he just give cat and the location of the file, he thinks I'm just reading it from the same machine. But internally, this set of programs which I have just highlighted in this dotted line, they will actually go and collect all these parts, read all these parts from different machines physically, collate them together, right, and then present them as one big file to the user, right? So this is how the entire storage and retrieval process of the data is abstracted out from the user, and that is called, and the set of programs which are doing it is called distributed file system. So please remember carefully, distributed file system is not a physical file system, it is just a virtual layer which takes care of storage and retrieval of the data in a distributed manner. Okay. So Hadoop uses a distributed file system to store the data. Okay. So let me directly talk about what is Hadoop. So if you just want to remember the definition of Hadoop, just remember it this way. Hadoop is a framework which allows you to do two important things. One is called distributed processing and another one is called distributed storage, right? Scaled out storage and a distributed processing. So if you can just relate it this way, let's say you have massive amount of data which you want to store, right? So when you have a big data which you want to store, the first problem which you have is, how do I store this data, or where should I store this data, correct? And that problem will be taken care by one of the component. So the processing of the data will be taken care by another component of Hadoop which is called MapReduce, MR, MapReduce. Okay. So these are the two components which is nothing but Hadoop. Okay. So Hadoop is a framework which has two core components, SDFS and MapReduce. Okay. So that's what is Hadoop all about, right? And in our trainings we will definitely get into the in detail architecture of these components. We'll do a lot of hands-on. We will also cover some of the ecosystem components of Hadoop and also the architecture and practical sessions of hands-on exercises of those components. But if you want to remember what is Hadoop, this is what Hadoop is. SDFS plus MapReduce is equal to Hadoop. It has two components. One component deals with the storage of the data, another component deals with the processing of the data. That's it, right? If you remember this way, you will never forget what is Hadoop. Okay. So some of the ecosystem components that I have just mentioned, which are all this, right? So I'm not going to talk about the use case and the overview of these components, but these are the components like Flume, Scope. You already understood MapReduce and SDFS. These are the two core components of Hadoop. Except these two, all the other components or all the other keywords or jargons that you have heard about, like Hive, Piglatin, Mahout, HBase, Flume, Scoop, Oozie, all these are called ecosystem components of Hadoop. Okay, and in our actual training we will be covering all these topics in detail with hands-on exercises. All right. So that's pretty much that I wanted to cover for today's session. So what we understood is what is big data, why big data is so much important, and what are the technologies that we can work with big data. So Hadoop is definitely one of the most effective technology to work with big data, and in our actual training we will understand why Hadoop is most effective technology to work with big data. We will compare Hadoop with different technologies and understand the technical differences of that, right? So we understood what is Hadoop, we just understood the overview of Hadoop and the ecosystem components of Hadoop, right? So I hope all of you have enjoyed this seminar. I hope all of you have understood whatever we have covered so far. I will again spend few minutes for questions. So please do let us know if you have any questions or comments about this webinar. Okay, so let us know if anyone has any questions, any comments. All right. All right then. Thank you everyone for your time. We hope you have enjoyed the sessions. Looking forward for all of you to meet in the actual training classes. Thank you so much. Have a wonderful day ahead. Thank you everyone.